All right, so we are going to look at this idea known as subtractive color mixing and how we can examine mixing different colors of ink to make new colors. And so we're going to continue to think about our model of light as being white light comprised of those three primary colors of light: red, blue, and green. And we're going to use that to look at not only how do objects reflect those colors of light to give us our perception of what color that object is, but also then how do we mix colors in a subtractive way to give us new colors based on that color theory. All right, so foundationally in subtractive color mixing, we do have to appreciate how objects appear, what color they appear, and why do they appear the color that they do appear. Now, we typically describe the color of an object based on the fact that we usually see it in white light, okay? And the colors that are absorbed by that object from that white light or reflected by that object from that white light are a property of that object itself, how they absorb and reflect various frequencies of light. But how we describe that color, of course, is because we see it in white light. So we're making an assumption that all the white light is hitting that object and either the portion of it being observed or reflected. So let's just start with that idea to begin with. Let's imagine that we have a green apple. So here's our green apple. And light is shining down on that green apple. And so that light is white light, and with the neon colors for the whiteboard, for this light board, it doesn't show as nicely, but we have white light, and white light we know is comprised of red light, blue light, and green light. So just to recap, when that white light hits that green object, that green apple, what's really happening? Well, the apple is taking that red light and absorbing it. It's taking that blue light and absorbing it. But that green light is hitting the apple and reflecting off. And that green light then hits our eye, and we perceive and see that apple as being green. All right, so that's just sort of that basic premise of colored objects. So let's look at how that relates then to our subtractive color mixing. Now let's imagine that we have a vat of magenta ink. So here is our magenta ink. All right, that magenta ink, why is it magenta? Well, the same principle we talked about over here. As white light hits the magenta ink, red and blue are both reflected, because we see magenta, which means we must be getting information about both red and blue light in the same spot at the same time in our retina. So again, we're using that model of those red, blue, and green making up that white light. We know that red and blue make magenta in an additive color mixing process. And so red light, blue light, and green light come down. So here's our red light, our blue light, and our green light. The red light bounces off, the blue light bounces off, and we see magenta. The green light, however, is absorbed by the magenta. All right, now let's imagine we have a cyan collection of ink. So here's my cyan vat of ink. Well, in a fashion similar, we know that red, blue, and green, here's my red, my blue, and my green, are hitting that cyan vat. I see cyan, so that tells me that blue and green are reflected, giving me that cyan color that I see in my perception. And red is absorbed into the cyan. Okay, let's put these two together. Let's mix these two colors together. So imagine that I bring them in very, very close proximity. I'm mixing the collections of magenta ink and cyan ink. Well, just like before, the red light hits the magenta and bounces off. That's an R. The blue light hits the magenta and bounces off. And the green light goes into the magenta. Well, in this very near proximity, I have the red light goes into the cyan. The blue light hits the cyan and bounces off. And the green light hits the cyan and bounces off, just like it did up here. But now, because that green light is so close to the magenta eats it up. And that red light that bounced off the magenta is so close to the cyan that the cyan eats it up. So the red that was reflected from the magenta is eaten by the cyan. The green that was reflected from the cyan is eaten by the magenta. And the only thing that's left to bounce off, to reflect, is blue. And so when I mix magenta plus cyan, I get blue. Now, why is this called subtractive mixing? Well, I'm taking away light as I mix them. I'm taking away information. Excuse me. I'm normally in magenta would have red reflect, but instead of it reflecting, it gets eaten up by that cyan. I'm taking it away. And normally with a cyan vat of ink, I would reflect the green, but I'm taking that away by the magenta. The magenta takes that away. So I'm subtracting out more light as I combine these two colors together. So magenta and cyan are blue. What about yellow and cyan? Well, yellow, remember, is going to reflect red and green because we see yellow. That must mean that material reflects red and green, but it takes away blue. And cyan, well, that reflects blue and green, but it takes away red. So the red that's reflected by the yellow is taken away by the cyan. And the blue that's reflected by the cyan is eaten up by the yellow. And the only thing that I'm left with that doesn't get eaten up is that green. All right, so let's round it out. What if we do yellow and magenta? Yellow, as we set up here, yellow is going to reflect red and green, but it's going to take away blue. Magenta is going to reflect blue and red, but it's going to take away green. So my green is taken away by my magenta, and my blue is taken away by my yellow. And I'm left with the red. So as I mix different colors, I see different outcomes based on what's being eaten up, taken away, and what remains reflected. Let's look at one more to fully elucidate this entire process of subtractive mixing. What if I combine them all? So if I take magenta plus cyan plus yellow, what do I get in this subtractive process? Well, following the same procedure, magenta is blue and red, takes away green. cyan is blue and green and takes away red. And yellow is red and green and takes away blue. So the blue from the magenta will also be reflected by the cyan, but it will be taken away by the yellow. The red from the magenta will also be reflected by the yellow, but it will be taken away from the cyan. And the green that's reflected from the yellow and the cyan will be taken away by the magenta. So this blue was taken away, but of course so was that one. This green was taken away, but of course so was that one. And this red was taken away, and of course so is that one. And so everything that gets reflected gets eaten by a different color. And we're left with nothing. And that, remember, is black. So as I mix these, taking away information, the subtractive process, I get my colors outcome. Now, you'll notice when I introduced this idea that I introduced the secondary colors of light first. These are the primary colors of ink. Secondary colors of light in an additive process, what results from adding colors together, is what we start with, the primary colors in the subtractive process. And whereas these, blue, green, and red, are our secondary colors of ink, secondary colors in the subtractive process. So that is the idea of subtractive color mixing, using the light theory to define what is our primary colors, and when we mix them, how they manifest and give rise to those secondary colors. All right, good job.